5.1 work, learning outcome. 5.1b, apply work done by a constant force and from a force displacement graph. Okay, so for exercise 1, calculate the work done by the force F. Okay, work done by the force F. If you can remember that I mentioned in lecture, okay, when you use equation or formula for work done equals to F dot S. Okay, so the force must be the component of force which is must be parallel to displacement S. Okay. So whenever you want to use this formula, work equals to F dot S. So the force, okay, the component of force should be the component which is parallel to the displacement. Okay, so you must multiply displacement S with component force which is parallel to the displacement S. Okay. So if the force is already parallel to displacement, you can simply substitute the force. Okay, the value of force F. But if it is not parallel, so you have to resolve into component which is parallel to the displacement S. Okay, let us do question A. Okay, so we can use work done equals to F dot S. Okay, so you have to identify whether F is parallel to displacement or not. So for this one, for case A, F is already parallel to displacement. So you can just simply substitute F and the displacement S. So work done by the force F 5 Newton is 50 joule or 50 Newton meter. And then how about B? So as you can see here, the displacement is in this area, okay, in this direction, and force is tilted. So force is not parallel to the displacement. So we have to determine the component of force which is parallel to displacement is the Fx. Okay, so we may use F equals to F dot S, where F should be parallel to displacement, so it is Fx or F cos theta. Okay, so substitute F and cos times cos 60 degree. Okay, and the displacement, so 5 cos 60 times 5. So work done by the force which is at an angle 60 degree to the horizontal is 12.5 joule. Okay, how about C? Okay, so C, okay, for C, this is F, force F, and then this is the direction of displacement S. So F is not parallel to displacement. Okay, so for this one, component of force which is parallel to displacement is F cos theta. Okay, so angle theta is in between force and displacement is 90 degree. So it is 5 cos 90 degree times displacement 5. So cos 90 degree equals 0. So work done by this kind of force is 0 joule. Okay, and then how about D? Okay, so for D, this is a displacement S, And then this is the force F. Again, this force F is not parallel to displacement. So you have to use F dot S. Okay. So F cos theta times S. So it is 5 cos 120 degree times displacement S 10 meter. So it is equals 5 cos 20 degree times 10. So it is negative 5 cos 120 times 10. So it is equals to negative 25 joule. Okay, negative 25 joule. Okay, work done is negative when work is done by the system. Okay, work is done by the system. Work is done by the object to overcome the force F here. Okay, to move to the right. Alright, and then how about E? So for E, angle between force and the displacement is 180 degree. Okay, so work done equals to F dot S. Okay, F cos theta S. So 5 cos 180 times displacement 10. So it is equals negative 50 joule. Okay, negative 50 joule. Okay, so work done is negative. That means work is done by the system to overcome the force F to move to the right. Okay. Okay, so example for this case for E is frictional force. So work is done by the object to overcome the friction to move the opposite direction of the frictional force. Okay.